Good everyone, welcome to my channel. In today's topic, we'll be talking about chemical equation. What is a chemical equation? We define chemical equation as a chemical transformation of one species to another. Hypothetically, we say, let's take this to be a species. We said, let A react with B to give C and D. Hypothetically, we said they came together to give this product. Any species that is found at the left-hand side is known as a reactant. Any of the species that is found at the right-hand side is known as what? As a product. In chemistry, we said here is means produce or yield. So what happened during a chemical reaction? There is an exchange of valency between the reacting particles. In this aspect, we're going to replace this hypothetical illustration to a chemical symbol. Let's use carbon, for instance, reacted with oxygen, for instance, to produce CO, for instance. I will explain this, how this product came about. In this aspect, we said carbon exhibits two valency. We define valency as the combining power of an element. This carbon exhibits a state 2 and 4, which is it has valency of 2 and 4, and oxygen have a valency of 2. So in this equation, we're going to talk about the state at which carbon exhibited this state is 2. We said it's 2. So what happened here? We are going to find any value that can reduce these two values to this lowest form. We said 2 can divide this way, 2 can divide this way. So if 2 should divide this way, I'm going to have 1. If 2 should divide here, you're going to have 1. So what in case if the two reactant is present, no value can reduce them to their lowest form? We'll leave it that way so that the valency can be exchanged automatically. In this aspect, these species are going to interchange, are going to exchange this valency. For instance, during those days, by trade by barter, they said when you are in need of rice or in need of beans, and you have someone that is looking for fish, and you have that beans to replace anything that you needed, you can replace it with your commodity. So in this aspect, let's bring that knowledge to this point, that this carbon and oxygen, they have a combining power, and the combining power is a 2. So what can reduce the 2 to the lowest form? We say they can divide each other by 2 to have 1 and 1. So in this aspect, carbon is going to take this one, oxygen is going to take this one. So what happened here is that C is going to take 1, oxygen is going to take what? Going to take 1. Bear in mind that this form of oxygen, which is in gaseous form, is that this one does not play any role in their combination. We can only use this tool for balancing this equation, but not in the chemical combination. In this aspect, we said when they come together, we said we have C1 and O1. In chemistry, we don't write C1 O1 in chemistry because we are trying to repeat ourselves. We don't want to be repetitive. We said we're going to write this carbon to be C. We already know that we have 1 carbon, we have 1 oxygen. Invariably, we have this equation to be in this format. So I will wipe this way so that I will write a complete equation to be what? CO. So this is in the gaseous form, carbon to oxide. So what happened at this point? And we said according to conservation of mass, law of conservation of mass, we say atoms can neither be created nor destroyed, but they can change from one form to another. So in this now, the reactant came together to produce this whole compound. So what happened? We say whatever that started the reaction actually ends the reaction. For instance, we said we have C at the reactant side, we have the oxygen at the reactant side to produce C and O as well. This idea is very common. For instance, now our domestic animals such as goat, for instance, now you notice that the goat gave birth to a big fowl environment. Everybody will say, ah, this is an abomination. But those can be reflected in our chemistry as well, that whatever that started the reaction actually ends it. That is why we have carbon here. We have carbon at the product. We have carbon at the reactant, oxygen at the reactant. We have oxygen at the what? At the product. So how many carbon are here? We say we have 1 carbon. Oxygen, we have 2. Carbon here is 1. Oxygen is 1. So for us now, we want to find every possible means to make this equation to be balanced. Whatever at the reactant side must be the same as the product. Here we have carbon 1, carbon 1. We have oxygen 2, oxygen 1. How can we balance this equation? We said we are going to add any value from 2 to infinity that will enable this equation to be balanced. So in this aspect, let's try to balance this oxygen. Try to balance this oxygen. In our own terms, this carbon and carbon they are the same. So what can make this oxygen to be 2? We said, let's introduce 2 here. Why can't we introduce these 2 between this carbon and oxygen? It is because they are chemically bonded together. We cannot break the compound to add these 2 to the compound. If, for instance, now we cannot break a brick to open it to add any value. That is a very simple illustration. So the compound is chemically bonded. So this 2 is going to be before this compound. So some student will ask me, uncle, teacher, why we would have added 2 here to make it this way? No, this compound is chemically bonded together. That is why it's called a compound. So this 2 is added at the surface here. Let me use the word surface. It's added at the surface here. So when we have here, we said 2 times 1 here, which is the oxygen, is so we're going to have 2 oxygen. So this oxygen and this oxygen is balanced. Moreover, this carbon here automatically became 2. So how can we balance this equation? So here, invariably, we can actually add 2 here to this point, so that 2 times 1 is going to make it what? To be 2. That is to say, at the reactant side, we have 2 carbon. At the product side, we have 2 carbon. At the reactant side, we have 2 oxygen. At the product side, we have 2 oxygen. In this case, this chemical equation is balanced and it is well written. Please, thank you. This is the end of this class. Please do well to subscribe to this channel for more lessons. Thank you.